Video, we will be talking about measures of average. There are three measures of average we will be discussing in this video. These are the mean, the median, and the mode. So our learning objectives will be to learn how to compute the mean of a data set, compute the median of a data set, and to compute the mode of a data set. And then we will compare the three measures of average. So let's begin by just talking about this concept of average. Are you an average college student? What does that even mean? According to a variety of sources found on the web, the average college student is 20 years old, lives on campus, and works off campus during the school year. She is female, talks to her parents every day, and comes from a family with an annual income between $50,000 and $100,000. She sleeps 6 hours a night, has $1,200 in credit card debt, and will leave college with $30,000 in total debt. If this doesn't sound exactly like anyone you know, don't feel bad. As we will learn in this section, the word average is ambiguous. There are a variety of ways to describe an average. So what one source considers average might not match someone else's thoughts. And with so many different facets to a person, it's possible that nobody exactly meets all of the average criteria. Our goal in section 11.3 will be to understand the different measures of average. And for the most part, we'll be focusing on finding and applying this idea of average to groups of numbers or sets of numbers. Okay. So an average might be considered a single number that represents a group of numbers. And there's different ways that we might decide what the best representative value is. In casual terms, average means the most typical case, or the center of the distribution. Measures of average include the mean, median, and mode. Let's suppose that an individual, let's just call him George, is in the market for a new job. George finds a small company, Vandelay Industries, which he's considering going to work for. While researching this company, George finds a flyer on which that company advertises that its average employee makes almost $150,000 per year. This sounds pretty darn good to George, so he accepts an entry-level position at a low salary, betting on quick advancement to that alleged average. Shortly after starting his career, while emptying the recycling bin in the copy room, just one of George's glamorous duties, he stumbles across a list of salaries for all employees at his new company. Let's investigate just how true the company's average salary claim is. Here is the salary list for Vandelay Industries. And we will use this data, these salaries, to study measures of average, which are more technically called here measures of central tendency. Okay, measures of central tendency. So let's get started. The first of the three averages we are going to look at is one called the mean. Now, there's a pretty good chance that when you think of average in a math class, what you're thinking of is actually called the mean. The mean, also known as the arithmetic average, is found by adding the values of the data and dividing by the total number of values. We can use some notation here to give a shorthand formula to represent the mean. So this right here is the Greek letter sigma, and it is used to represent the sum of a list of numbers. If we use the letter x to represent data values, then sigma followed by x means to find the sum of all values in a dataset. Using this notation, we can formally define the mean. The mean is the sum of the values in a dataset divided by the number of values. If x1, x2, x3, so on, all the way up to xn are the data values, then we will use this symbol. We call this symbol X bar, right? Because it's literally X with a bar over the top to stand for the mean. So then X bar equals X1 plus X2 plus X3 plus all the way up to Xn divided by n, where n is the total number of values. In shorthand, we can write this as sigma x divided by n, since the sigma x literally means to add the values together. And again, the symbol here is read as X bar, and this is the standard symbol that is used to represent the mean. Okay, so now that we've formally defined the mean, let's go through an example where we compute the mean of a data set. So we want to find the mean of all salaries for the employees of Vandelay Industries, and then we want to answer a couple of questions. Is the company's claim technically truthful? And do you think it's deceiving? So let's find the mean, and then we'll answer those questions. Now, to make the math easier, let's go back and look at the data here. Notice that all of the numbers in this data set are numbers in the thousands. So to make the math easier, I'm just going to drop the 3 zeros. So for 58,000, I'm just going to use 58. For 65,000, I'm going to use 65, and so on. That'll just make the math a little bit easier. So what that calculation looks like, it's 58 plus 65 plus 944 plus 20 plus 52 plus 51 plus 53 plus 55 plus 50. Divide. There was a total of 9 employees, so 9 salaries here. This works out to be 149.8. And again, these are all values in the thousands, so let's write this as a dollar amount in the thousands. It would be 149,800. Okay, so this is the mean salary of the 9 employees at the company. What was the company's claim? Their claim was right here, right? George finds a flyer on which that company advertises that its average employee makes almost $150,000 per year. This is the average salary by one criteria, that criteria being the mean, okay? So the claim is actually, in fact, truthful, right? Provided that by average you mean the mean. So the technically truthful, but is it deceiving? Absolutely, it is. And that's because there is only one person in the company that makes more than $65,000 per year. That would be the owner, right? Go up here, Newman, right, who makes a hefty salary of $944,000. Everybody else's salary is much lower, right? Nowhere near that $150,000 value. So the only reason he can make this claim, right, this claim right here, is because his one salary skews the mean to be much higher, right? Higher than most of the salaries of all the other employees. So yes, that claim is technically true, but also deceiving, okay? So let's look at another average. This next one is the median. According to the National Organization of Realtors, the mean selling price for existing homes nationally in November 2021 was $372,400. The median selling price, on the other hand, was $353,900. Since both of these are measures of central tendency. How can they differ by almost $20,000? What exactly is the median? In this case, the median tells us that half of all homes sold during that month were priced above $353,900, and that half were priced below that amount. In short, the median of a data set is the value in the middle if all values are arranged in order. The median will either be a specific data value in the set, or it will fall in between two values. Here's how we find a median. Step 1. Arrange the data in order from smallest to largest. Actually, largest to smallest will work too, whatever makes you happy. Smallest to largest is what's more typical. If the number of data values is odd, the median is the value in the exact middle of the list. If the number of data values is even, the median is the mean of the two middle data values. In other words, you would take the two middle data values, add them together, and divide by 2. Let's go back to the salaries of the employees for Vandelay Industries. This time, we want to find the median salary, and then we want to see how that compares to the mean. So that's the first question here. Let's start with that. So first, we need to arrange the salaries in order. We'll arrange them from lowest to highest. If we go back and look at that table and arrange the numbers from lowest to highest, this is what we get. 20,000, 50,000, okay, 51,000, 52,000, 53,000, 55,000, 58,000, 65,000, and then 944,000. Okay. There should be 9. Let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it looks like we got all of them. Okay. There are 9 salaries listed. So that means the median will be the salary right in the middle. There will be 4 salaries less and 4 salaries more. This makes it the 5th salary on the list, right? So 1, 2, 3, 4. Just circle it or box it. That's the median, right? Is that right? Oops, sorry. That is incorrect. It's actually the 5th salary. Sorry about that. 1, 2, 3, 4, 5. So it's 53,000, right? So there should be 4 salaries below. 1, 2, 3, 4. And 4 salaries above. 1, 2, 3, 4. It's the number right in the middle. This is a whole lot less than the mean, right? Remember, this is the median. The mean, which was X bar, was 149,800. The median is 53,000. The mean was 149,800. There's a huge difference between those two numbers. And the median is actually, in this case, a much more reasonable measure of average for these data. In this case, we would call this number, the 944,000, an outlier, because it is much, much larger than most of the other data in the data set. When you have a data set that has outliers, the outliers tend to affect the mean by a lot, but they don't affect the median in the same way. So that's why when you have data sets that have outliers, the median is typically a better choice for an average for that data set. Okay. What was the second question? Find the mean and median if Newman's salary is left out. what can you conclude? Okay. All right, let's start with, let's just do this. Let's find the mean first. Okay. Again, to make the math easier, I'm just going to drop the 3 zeros. So the mean, call it x bar. Again, we're finding the mean without Newman's salary. We're getting rid of this outlier, right? So that would be 20 plus 50 plus 51 plus 52 plus 53 plus 55 plus 58 plus 65. Okay. And we'll divide this. Now there are only 8 numbers. So this works out to be 50.5. And now we'll put the 3 zeros back, or we'll multiply by 1,000 to scale this back into the thousands. So 50,500. This is my new mean when I drop Newman's salary. To find the median without the outlier, again, I'll just list the numbers, but without that last number. Okay. 51,000, 52,000, 53,000, 55,000, 58,000, 65,000. Okay, just make sure there's 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is an even number, so that means there's actually 2 middle values. Those would be 52,000 and 53,000. Let's just circle those, right? These 2 values are in the middle. There's 3 values below, 3 values above. Now, the median can only be a single number. It can't be 2 numbers. So the median is the number that's exactly halfway in between these 2 values. Okay. And we can find that by adding them together and dividing by 2. Okay, divide by 2, and we get a median here of 52,500. Okay, so here's what's interesting about this, right? When we include the outlier, when we include Newman's salary, the mean and the median are very, very different from each other, right? The mean is much higher than the median. If I don't include Newman's salary, the mean and the median are not all that different from each other, right? We're talking about 50,500 versus 52,500, right? These 2 numbers are much more closer in value than these 2 numbers are up here. Okay. So the median was almost unaffected by throwing away the largest value, but the mean changed dramatically. So this is exactly why the mean, in this case, was a poor measure of average for this particular data set, right? Because the one very large value has a great impact on the mean, but not so much on the median. Let's move on and talk about our next measure of average, which we call the mode. The mode is usually described to be the most typical case. This is just the value that occurs most often in a data set, more often than any other data value. A data set can have more than one mode, or no mode at all. These situations will be shown in some of the examples that follow. Start with example 3. This data represents the duration in days of the final 20 United States Space Shuttle voyages. Find the mode. Now again, the mode is really just the number that occurs more often than any other number. So I could just kind of carefully go through and look at these numbers and figure out which one occurs the most often. But it's another thing I could do is I could actually create a frequency distribution, and that would be relatively easy. I'll do a column which I'll label days, and another column which I will label frequency. Okay. So if I look at the numbers here, the smallest number is 10. The biggest number is 15, right? So days would be either 10 or 11 or 12 or 13 or 14 or 15. And then for the frequencies, I'll just count, right? So let's start with 10. I'm going to go through, and everywhere I see a 10, I'm going to count it and then cross it off. So there's a 10, cross it off. That's actually the only one. So this frequency was 10. Let's do 11. Here's 1, 2, looks like just 2. Then 12. I've got 1, 2, 3, 4, 5, 6, 7. Okay, that one has 7. Then we've got 13. 1, 2, 3, 4. Looks like 4. 14. What do we got here? Actually, 14, none of them were 14, so that's just going to be 0. And then the rest were 15. So 1, 2, 3, 4, 5, 6. Okay. So when I arrange it in the data as a frequency distribution, then it's much easier to see which data value occurs the most. It's clearly going to be the number 12 here, right? The number 12 occurs 7 times, which is more than any other value in the data set, right? So the mode is 12. Okay. Let's look at another example. The number of Atlantic hurricanes for each of the years from 1999 to 2021 is shown in the list. So we want to find the mode of this data set. Okay. Again, there's multiple ways we could approach this. We could do the frequency distribution like we did with the other example. That would take a little bit more effort because there is a larger variety of different numbers in this data set. So maybe we'll just kind of work down the list. So like the number 8 occurs 1, 2, 3, 4 times, right? So let's just kind of see if we can figure out if there's any other numbers that occur more than 4 times, right? So the number 9 occurs 1, 2, looks like 2 times. The number 4, I see 1, 2 times. 7 occurs 1, 2, 3, 4 times. So that one's tied with 8, right? 15, I see just once. 5, just once. I see 6, 1, 2, 3 times. I've looked at 8, 3. Yeah, if you kind of scan through that carefully, it looks like 7 and 8 are the 2 values that occur the most often. Those 2 values occur 4 times. No other number occurs with that high level of frequency. Okay, so this data set actually has 2 modes. 7 and 8 are both modes. Okay. In the context of this data, this means that over that 22-year span, the most common number of Atlantic hurricanes was 7 and 8. Okay. So example 4 shows that it is possible for a data set to have more than one mode. It's also possible for a data set to have no mode if there's no data value that occurs more than once. The mode is probably most useful when data are classified by groups or categories. In fact, it's the only measure of central tendency that even makes sense when the data values aren't numbers, right? So far, things like a mean or a median only make sense when we're talking about numbers, right? It's because the mean, you add up the numbers and you divide by the number of numbers. The median, you arrange the numbers in order, find the middle value. But the mode doesn't have to be a number. It could be a category, right? In example 5, it says a survey of the junior class at Fiesta State University shows the following number of students majoring in each business field. Find the mode. So 1,425 were majoring in business. 878 majored in liberal arts. 632 in computer science, right? 471 students were majoring in education. 95 students were majoring in general studies. The mode is just the value that occurs the most frequently. In this example, that's not a number, it's a category. It would be business. Okay? Business is the mode because it is the category that has the highest frequency, right? So the mode does not have to be a number. Okay, we've looked at three measures of average, the mean, the median, and the mode. So let's finish this section by just comparing these measures of average. Okay. Let's see here. All right. So yeah, for comparison, we can go back to the salary data, right, from Vandelay Industries. And just one more time, let me just list those salaries out, right? So we had 20,000, 50,000, 51,000, 52,000, 53,000, okay, 55,000, 58,000, 65,000, and then that big one, 944,000. Okay. So the mean we calculated to be 149,800. We'll put a dollar sign there because these represent dollar amounts. The median, the number in the middle, we determined to be 53,000. How about the mode? For this, the mode is defined as the data value that occurs the most frequently. Well, in this data set, all 9 values are different. There is no value that occurs more often than any other, so there is no mode. None for this data set. Okay. So if we're talking about the average that makes the most sense when describing this data, it would be the median in this case. But generally, if you have a data set that does not have an outlier like this, in data sets that don't have outliers, generally the mean is often considered the preferred one. And that's kind of because the mean is the only average that actually takes into consideration every single value in the data set. But clearly, when you have an outlier like this, it skews the mean to the point where it's not a very good representative value way to describe most of the values in the data set. Okay. So we can kind of wrap up by looking at this table down here, which compares the 3 measures of average and gives some of their strengths and weaknesses. The mean. Strengths, it's unique. There's exactly one mean for any data set. It factors in all values in the set. It's easy to understand. Weaknesses, though, it can be adversely affected by 1 or 2 unusually high or low values. It can be time-consuming to calculate for large data sets. The median, it divides a data set neatly into two groups. It's not affected by one or two extreme values. Those are the strengths. Weaknesses, it can ignore the effects of large or small values, even if they are important to consider. And yeah, so that's that's the main weakness there. Okay. Mode, very easy to find. It describes the most typical case. Can be used with categorical data like candidate preference, choice of major, etc. Weaknesses, though, it may not exist for some data sets. It may not be unique, and it can be very different from the mean and median if the most typical case happens to be near the low or high end of the range. So that's a good summary of those three different averages we've talked about, and that's where we'll end this video today. Thank you for watching.